There's a persistent chill in the scientific community these days, as the newly discovered interstellar visitor 3I/ATLAS drifts through our cosmic neighborhood. What began as a fascinating chance encounter has turned into something far more unsettling. The possibility that this object, coming from beyond our solar system and now hurtling inward, could someday collide with Earth's moon. The idea is unsettling in and of itself, and the implications are chilling. It's not just the impact that's worrying, but the cascade of cosmic consequences it could trigger. Astronomers identified 3 I/ATLAS only recently, yet its trajectory and speed immediately marked it as extraordinary. The fact that it originates from outside our solar system means it did not form from the same protoplanetary disk that gave birth to Earth, the Moon, and their celestial siblings. Its arrival into the inner solar system is remarkable on its own. But what has provoked alarm is the suggestion that its current path might radically intersect the Moon's orbit, leading to a potential high-velocity strike. The sheer number of variables makes this an alarming scenario. A foreign object traveling at an extraordinary velocity, possibly on course to intersect a body as large and gravitationally influential as our Moon. If 3I/ATLAS were to slam into the Moon, the scale of the event would dwarf common lunar impacts. Imagine a mountain-sized object striking a satellite that humans visit, colonize, and rely upon for both science and future ambitions. The Moon is not a passive participant in the solar system. It exerts tides, stabilizes Earth's axial tilt, and offers a platform for human exploration. A high-energy impact would interfere with all of that. The moment of collision would convert pure kinetic energy into shock waves, molten rock, ejecta flung into space, and perhaps long-term destabilization of lunar regolith and orbit, affecting scientific missions, lunar infrastructure, and the human future in space. The consequences are profound. Because 3 I/ATLAS is an interstellar object, its composition may differ in fundamental ways from standard solar system comets and asteroids. Observations hint at unusual ratios of outgassing, unexpected chemical signatures, and a hyperbolic path that signals it is not bound to the Sun. That means the impact scenario involves not just a conventional asteroid-moon collision, but something whose physical properties, mass, density, and structure, might be completely foreign. The speed of the object alone would elevate the danger. An object entering the lunar environment at tens of kilometers per second carries an energy payload that could equal the largest meteor impacts in Earth's geological past. The Moon lacks a thick atmosphere, which means any impact is far more direct than on Earth. There is essentially nothing to slow the object. It would arrive at full velocity, strike the lunar surface, and release practically all its kinetic energy into excavation of the surface, generation of heat, creation of a crater far larger than typical lunar craters, and ejection of debris. Some of that debris could escape the Moon's gravity entirely and travel into space, perhaps intersecting Earth's orbit, or even raining down on our planet in the weeks to follow. In other words, the Moon could become a blast site and a secondary source of hazard for Earth. Moreover, our lunar operations, current missions, planned bases, and satellites orbiting the Moon are all at risk. An object of the size and energy presumed for 3 I/ATLAS could damage lunar orbiters, destroy nearside infrastructure, and create a field of high-velocity ejecta that poses hazards for many years. The Moon is not simply a passive body. It hosts ambitions of human settlement, scientific labs, and satellite positioning for Earth observation and communications. A catastrophic hit would not just scorch a crater. It could render parts of the Moon unusable for decades. In turn, there are implications for Earth beyond the immediate blow. While the Moon is smaller than Earth, and therefore an impact there doesn't compare to a direct Earth strike, the interconnectedness of the Earth-Moon system means that lunar disruption could translate into Earth effects. For instance, large volumes of lunar dust and ejecta could enter Earth's space environment, increasing the hazard for satellites and spacecraft. Changes in the Moon's orbit or rotation, Even subtle ones could alter tidal patterns on Earth, affecting climate, ocean currents, and coastal systems. The moon's stabilizing influence on Earth's tilt is one of the reasons life on land developed as it did. Disruption to that system could feed back into Earth's environment in unpredictable ways. Then there is the psychological and political dimension. The discovery of an interstellar object already stretched public imagination of space threats. The idea that this visitor might smash into the moon magnifies fears. Governments and space organizations would be forced to confront scenarios previously relegated to science fiction. Questions of lunar defense, impact mitigation, monitoring of interstellar objects, and international coordination of response would move to the forefront. The moon, once viewed mostly as a target for exploration, would suddenly become a zone needing protection. Human aspirations to establish a long-term presence on the moon could be re-evaluated in light of this threat. We must consider the scientific opportunity, even amid the fear. If 3 I/ATLAS did strike the moon, the resulting crater and exposed geology could offer unprecedented access to interior lunar materials. Scientists could examine ejecta, study shock metamorphism, and learn about both lunar structure and the interstellar object itself via material embedded in the crater's rim. But that opportunity comes with a massive price tag: destruction, hazard, and uncertainty. It is far preferable to avoid the impact altogether than treat it solely as a chance for science. One of the more daunting aspects of this threat is the short warning and limited control. The object is already in motion, its velocity so high and path so radical that any attempt to alter it would demand technologies we currently do not possess. Usual planetary defense discussions address near-Earth asteroids, but here the target is the moon, and the intruder is interstellar. Given the object's origin, its behavior may defy the patterns we rely upon, making prediction more difficult. As of now, there are significant uncertainties in its orbit, mass, and structure. That uncertainty itself heightens danger. If the object is larger or denser than estimated, the impact consequences scale dramatically. The potential impact onto the moon also raises issues of timing. If the strike happens while humans are present on the surface, whether via lunar bases or surface expeditions, the risk to life becomes real and immediate. Even if no human presence exists at the moment, future missions could be disrupted. Planning of lunar infrastructure must now incorporate possibilities previously considered remote: high energy impacts altering the lunar surface, satellites knocked out, dust clouds reducing visibility, and possible debris trajectories intersecting with Earth or lunar orbits. The timing might coincide inconveniently with other space operations, exacerbating logistical complications. Another dimension is the chain reaction across space assets. A major impact on the moon could send fragments into Earth orbit, increasing the hazard for satellites and the International Space Station or future high-orbit platforms. Moon-observing telescopes, lunar telescopes, and lunar orbiters could all be at risk. Space agencies may need to reconsider the resilience of orbiting infrastructure. Furthermore, if debris from the lunar impact reaches Earth, there is a risk of meteor showers or micrometeoroid damage to spacecraft and satellites. Echoes of the lunar strike could be carried to Earth. The moon is, in essence, a keystone in humanity's longer-term plans for space. From building a staging ground for Mars missions to harvesting lunar resources, any serious disruption undermines our pathway to becoming a true multi-planet species. If 3.I/ATLAS strikes, it could force a reset in lunar strategy. Bases delayed, costs increased, engineering challenges multiplied. The psychological toll of a moon strike could redirect investment dramatically toward Earth-based exploration, or even dampen public interest in space expansion for a period. Moreover, the statistical odds of such an event change how we perceive risk in space. If we accept that an interstellar object can strike the moon, previously assumed safe zones must be rethought. Space defense frameworks that focus almost exclusively on Earth impacts may need to expand to cover satellites, the Moon, Mars, and other bodies. The scenario shifts from could an asteroid hit Earth to could a visitor from another star strike any of our assets in space? It widens the threat landscape. And widening the threat means we must also widen our monitoring, detection, and perhaps even mitigation networks beyond Earth-centric ones. In the cosmic context, such a moment would serve as a harsh reminder of our vulnerability. The Moon appears unshakable in the sky, steadfast and familiar, but it is just another celestial body in orbit, subject to the same risks as everything else in space. If 3I/ATLAS were to slam into it, the Moon's constancy would be shattered. For centuries, humans have looked up at it as an unchanging companion. Suddenly, it would become a stage for high-energy cosmic violence. The conceptual shift is profound. Our satellite is not immune,